Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.2, Problem 3. This is Section 15.2, it's problem number 3. We want to find the integral of x squared plus 5 in parentheses to the 12th power times x dx. Now, the intention is that we solve this using the substitution method. This one could actually be solved without it, but it would be such a hassle. You would have 12 sets of parentheses. I just put dot, dot, dot. That would have to be FOILed out. There'd still be an x dx on the outside. It could be done, but that's a lot of work. So a better way to do it is use the substitution method. So the first step is choose u. You have a few choices for u. Basically, it's the stuff in parentheses, which works very well for us. Stuff in the denominator. There is no denominator, so that choice isn't really viable for this problem. Stuff under the root, there is no root for this problem. Power of e, there is no e for this problem. The only choice of the ones you have that fits in any way is the stuff in the parentheses, which in this problem is x squared plus 5. Notice just what's inside the parentheses. I do not include the exponent of 12th power, just what's inside, the x squared plus 5. The next step is find the derivative of u. So the x squared has a derivative of 2x. And again, what's happening is the exponent of 2 comes down times the number in front, which isn't written, but it's understood to be 1. 2 times 1 is 2. X to the 1 less power, that second power drops down to a first power. The 5 has no x with it, so its derivative is 0. It pretty much just drops out of the derivative. And at the end, you put dx, basically for derivative with respect to x. So now the third part of the process is to rewrite this original problem with the x's in terms of the new variable u. So integral of my x squared plus 5 in parentheses to the 12th power becomes simply u to the 12th power. The x dx, ooh, I have a little bit of a problem there. I have x dx that's pretty close. I have a 2. What do I do with that? Well, I can cancel that too, right? This is an equation, right? It has an equal sign, so I can do whatever I want as long as I do the same thing on both sides. So on both sides, I'm going to go times a half. That's legal. So on the right side of the equals, 2x dx times a half, the 2's will cancel, leaving me with x dx, which is exactly what I want to replace. So I know that the x dx that I need to replace is equal to 1/2 du. Now I have the original problem written in terms of a new variable where I don't have to FOIL out 12 sets of parentheses. This 1/2 in the middle is kind of a weird thing. Since it's just a number and not a variable, I can write it in the front of the integral symbol. So I can rewrite this as 1/2 the integral of u to the 12th du. Now this is a very straightforward integral to solve u to the 12th. It's a big exponent, but you're going to have the number in front, which is 1, over the old exponent plus 1, so 12 plus 1, u to the old exponent of 12 plus 1, plus a constant. Now don't forget, there's times a half in front of that whole thing. So I'll have my 1/2 in front times 1 over 12 plus 1 is 13, u to the 12 plus 1, which is 13, plus a constant. So now those two fractions in front, I should clean that up. Multiplying fractions is easy. I'll just do top times top. 1 times 1 is 1. Bottom times bottom, 2 times 13 will be 26. So I have 1 over 26 u to the 13th plus a constant. And again, that is the answer, but it's not in the form that we can leave it in. We have to state the answer in terms of the original variable x. So my final answer will be 1 over 26, that fraction that I had in front. And instead of u to the 13th, it'll be what u is equal to. X squared plus 5 to the 13th. And there would be plus a constant. And that's the same answer we would get if we did the original problem out the long way by FOILing out 12 sets of parentheses and collecting the like terms. And if you did that whole process correctly without making any simple errors, you would get a result of 1 over 26 times x squared plus 5 in parentheses to the 13th power plus some constant.